So we're going to do iterated integrals and area. In chapter 5 of our textbook, we learned how the definite integral of a single variable function provides area under the curve. Okay, integral a to b f of x dx is equal to the area under the curve of f from a to b. That's what this is equal to. Okay, in this chapter 13 of this textbook, we will learn that integration applied to a multivariable function gives us a volume under the surface. Okay, volume under the surface versus area under the curve. So you have this multivariable function fxy. Okay, some surface okay, and then get the z-axis, x, y-axis coming through here, and then this projects down. And it creates a volume that you're calculating on this iterated integral. Okay? So let's start with fx, first partial with respect to x of the function, is equal to 2xy. Then f of xy is equal to the integral of fx with respect to x. All right, so what does that look like? That's the integral of 2xy dx. Okay, this differential says I'm going to integrate with respect to x, so what do I treat y as? So I'm going to treat y like a constant. Okay, meaning I can pull it out. So I'm going to pull that constant 2 out. I'm going to pull that constant y out. So I'm going to pull the 2y out. And I'm going to integrate x with respect to x. And so this is equal to 2y. Integral of x is x squared over 2. Then plus a c. Now, the thing about this c, whenever I integrate with respect to x, that c could just be a number. But remember, y is treated like a constant as well. So it could be this constant could be a function of y, and it would still be a constant. So when the way we designate a function of y is c, a constant in terms of y. Right? So just to remember, just to recap, like if I took the partial with respect to x of like 7 sine y, that is still equal to 0. Okay, that's a constant with respect to x. So my answer is 2y x squared divided by 2, and what happens to my 2's? They cancel, plus c of y. Okay? All right. So, let's do another example. So to do an indefinite, let's do a definite integral. So the integral from 1 to 2y of 2xy dx. Okay, what are we integrating with respect to? We're integrating with respect to x. So I'm going to treat all other variables than x like a constant. Okay. So once again, I integrate. And so whenever I integrate 2x with respect to x, I get x squared, y, evaluated from 1 to 2y. Now if you'll remember, when we had Cal 1, we did the definite integral was equal to the antiderivative evaluated at b minus the antiderivative evaluated at a, where a and b were those limits of integration. Yeah? So this is equal to capital F of b, the antiderivative of the little f function, minus capital F of a. Okay, so here it's gonna be, what am I plugging into? I'm integrating with respect to x, so everywhere I see an x, I'm gonna put 2y. So this is 2y squared minus 1 squared, which produces 4y cubed minus y. Okay? All right. So, in general, what's happening here? The integral from a function h1 of y to a function h2 of y of fx, first partial with respect to x, of xy dx is equal to f evaluated at the upper limit, h2 of y, comma y, minus f evaluated at the lower limit, h1 of y, comma y. All right, so that's literally what we did here. We plugged in, just like we took here, and we plugged in there. We took here, we plugged in there. That's what's going on. This piece here. Okay? And so, same thing works when we integrate with respect to y. The integral g1 of x to g2 of x. These are functions of x. So the partial with respect to y of xy dy. So now I'm going to integrate with respect to y. This is going to get me f of x comma g2 of x minus f of x comma g1 of x. So g2 plugs in g2 here, and g1 plug in for my y value right there. Remember, I'm integrating with respect to y. All right, so let's try, instead of just seeing the general case, let's try one where we integrate with respect to y here, so you see an example of that. Have that for your notes. Integral 1 to x of 5x cubed y to the negative 3 plus 6y squared dy. Okay, so what am I going to integrate this function with respect to? I'm going to integrate with respect to y here. All right, so that means I'm going to treat the numbers like 5 and variables like x cubed as a constant, and everything else, everything that has y's, then I'm going to integrate those things, those pieces. Okay, so how do I integrate? I add 2 and divide by it. Okay, so the integral here is going to be 5x cubed, that's my constant. Add 1 to that, that's y to the negative 2 divided by negative 2. Plus y to the 3, add to it, divide by it. And then I integrate from 1 to x. So what am I plugging in here? Well, remember, we are integrating with respect to y, so that's my variable that I'm going to be plugging in for. So everywhere I see a y, I'm going to plug in an x for the first one. So that's 5x cubed, and then I have x to the negative 2 over negative 2 plus 6 and then x cubed over 3 minus, okay, now I'm going to plug in 1 everywhere I see a y, so I have 5x cubed 1 to the negative 2 over negative 2 plus 6 times 1 cubed over 3. All right. And so if I simplify this out, I'm going to have 5x cubed over negative 2x squared plus 6x cubed over 3, and then minus a minus, that's going to end up being plus 5 over 2 x cubed. Okay. And then plus and a minus, so that's going to get me minus 6 divided by 3 is 2. Yeah, that looks good. All right, so I'm going to combine like terms where I can. This is going to reduce. That's going to end up being 2x cubed. This is going to be minus 5 over 2x because the x's are going to cancel. All right, so I have 2 and then plus 5 over 2. So what is that? 4 over 2 plus 5 over 2 gets you 9 over 2. 9 over 2 x cubed. Okay. And then minus 5 over 2 x and then minus 2. All right. So when we integrated this expression with respect to y, we ended up with a function, okay? 9 over 2 x cubed minus 5 over 2x minus 2, all right? So the limits of integration are a function of x. If you notice up here, the limits of integration are 1 and x. Those are functions of x, meaning what? I'm integrating with respect to y, so this is y equals 1, and this is y equals x. Y equal 1 and y equal x are functions of x. So the final answer will be in terms of x when you integrate with respect to y. Okay, so that's something to note there. So the limits of integration are functions of x. So your final answer is in terms of x when we integrate with respect to the y variable dy. Okay? All right. So let's take it one step further. Let's take this a step further. How do we do that? All right, let's take our answer here. Okay. Which, if we think about it, this was equal to the integral from 1 to x, 5x cubed, y to the negative 3, plus 6y squared dy. Okay, and now let's integrate this thingy from 1 to 2 with respect to x. Now remember that red thing there is equal to what? It's equal to 9 over 2 x cubed minus 5 over 2x minus 2. And we're integrating with respect to x. Okay. So whenever I do that, what's going to happen? I'm gonna get a number. Okay. So you guys all know how to integrate this. If I do this, add 1 to it. So 9 over 2, x to the 4 over 4. So that's going to be divided by 8. okay, minus 5 over 2x, add 1 to it, divide by it, so that's going to be divided by 4 in the denominator, minus 2, and then raise that from 0 to 1, divide by 1, and I'm going to integrate that from 1 to 2. Now you can type that, once you get the antiderivative here, you can just type that into your calculator if you want to, or you can do the arithmetic. I don't really care. I'm just going to type it in my calculator, math, and I'm going to go to my f integral. So I'm going to do from 1 to 2. I'm going to do 9 divided by 2 x cubed minus 5 divided by 2 x minus 2. I'm going to get 11.125, which that looks like an eighth. If I do math frac, I'm going to get 89 over 8. Okay? 89 over 8. All right. So the question is, what in the world is 89 over 8? What is this number? All right. What is this number? And so we are going to answer that question with the definition of the iterated integration process. And I'll do